Okay, so here we are at the first uh, practice lesson of Unit 6, all about dilations. And it tells us that this prime triangle, XYZ prime, is used by, or was created by dilating a smaller smaller triangle, XYZ, not prime. And the point of origin was O, and the length of xy is 2, so this length of xy is 2, right? So the length of here from x to y, I'll make it nice and pretty in color coded. Xy was 2 here, and this is the before dilation, or as the pre-image, before, also known as the pre-image, and then the after dilation is the image. This is the after dilation. It was 4, so pre, after, because of the prime marks. I know that because of the prime marks up here, right? The prime marks after dilation. This is 4. This is after dilation, right? So this is the image. Okay, so this is 4 and 2. All right, so immediately just by looking at this, the scale factor. Remember your scale factor. Scale factor is your after divided by your before. Or you can think about it as your prime divided by your not prime, right? Or whatever, right? So that's the little reminder about all that stuff, right? And remember, if your scale factor is greater than 1, the figure got bigger. The figure grew, right? It got bigger. If the scale factor is less than 1, the figure shrank. So a couple little reminders about scale factors. Scale factor, right? So this is my after image. So my scale factor here is going to be, doesn't matter which side you pick, right? I gotta pick this side, I gotta pick this side, I could have picked the hypotenuse, but it only gave me x and y, right? So the x to y value before is going to be the length of x y prime divided by is my prime, or my after, divided by the x y before, or not prime, the length, right? So that's my after and before the dilation occurred. So that's going to be equals 4 divided by 2, or equals 2 to 1. Right, so here we go, XYZ, my not primes. This is the pre-image, right? And the primes are my image. Okay, and this is the point of dilation here. If you line up all of these here, these little dotted lines, right, you intercept all of the corresponding points, the y and the y prime. This is my prime point here. This is the not prime. You got my x and my x prime. Line all those up. The point where they all intercept, right? The point that they all intercept is the point of dilation. So it's going to be O. Also, if you don't know all of them, you can just line one of them up, and the the ratio of this to this is the scale factor, right? So this is going to be, this will be twice the length of this. So the length of this to here is going to be the scale factor of here to here. So the scale factor is 2. The length from here, from this point, the after point, is going to be twice as long as the distance from the initial point before, from here to here. So if this was 3, this would be 3 times as far from here as this was to here. So that's another way to tell what the point of origin was. Okay, so determine the dilation ratio. So I already did that. It's 4 divided by 2. Scale factor. Also the dilation ratio equals dilation ratio equals 4 to 2 equals 2. Alright. If the length of, so if I knew the length of YZ was 2 divided by the square root of 5, right? Y prime Z prime, what would Y this be? Well, this is a simple ratio here, right? So if you wanted to see how that was all set up, that would be the Y prime Z prime is Y to Z equals 2 to 1, right? That's my scaling factor, or my dilation ratio, equals 2 to the square root of 5 divided by, I'm looking for, this is x, right? So I just need to cross multiply. So 2 times x, 2 times, therefore 2 times x equals 1 times 2 square root of 5, and then therefore x equals 2 divided by this 2 times square root of 5 divided by 2, therefore x equals square root of 5. Okay, simple ratio. The two things that are equal together go on one side of one side of the ratio. The other one goes on the bottom. You could have flipped this and it would have been just as right. So this is what I was talking about as far as the ratio of one thing to the point of origin. All right, so the ratio of xz, right? Xz, this is this little guy, to, it's going to be the same to xz prime, right? This is going to be the same ratio but inverted, right? So it's going to be, since it's each one of these is going to have the same scaling factor or dilation ratio, right? It's this divided by this. Okay, so the scale factor would have been, you could have gotten the scale factor by going z prime x z prime. Let me make that better. X prime z prime divided by x z. Okay, and that would have still equaled 2 over 1, right? Or just 2. Right, or just 2, right? So if you wanted to figure out what this ratio was, right, this is the ratio of this to this, right? The ratio of this to this is 2. So the ratio of this to this is the inverse of this. So if you wanted to say that, this equals the inverse of the scale factor, which equals 2 inverted, which equals 1/2. Okay, and then it's asking you what the ratio of y to y prime is. So y to y prime, so the distance between here and here, and then the ratio of the distance from here to here is. Okay, so this is saying what? So if you're figuring out what the distance from here to here and the distance from here to here. Okay, so this is just a single 1-to-1 ratio. Alright, so this is, you get this from the scale factor. Scale factor is 1 to 2, right? And the distance from your origin, your point of origin, can help you determine how far the 2 points are going to be from each other, if you know the scale factor, right? So if scale factor is 1/2, it's 2 to 1, 2 to 1, 2 to 1. So your initial point is going to be 1 unit away, right? And since your second point is going to be 2 times, twice the distance from your first point, if your scale factor is 2 to 1, right? So since that this is 2 of your single, like your first one, is twice as far away, your y, your 0 point, your O point to y, right, is twice as far away as your single y to y is away. So that means these two are equal in measure, right? So if these are equal in measure, then it's going to be a 1-to-1 ratio. If this was like a 3-to-1 ratio, then this one would be all the way out here, and your scale factor would be like a 3 to 1, right? Because it would be this ratio would be like a 2-to-1 ratio. Okay. All right. So next, we have determining the slope of these line segments and the distance of these line segments. So we'll be using some Pythagorean's theorem and some simple rise over run calculations here. All right, so we have y and z. So y and z. So to figure out, this is going to be rise over run. So a rise is how much it goes up, right, over the distance of how much it goes over. Okay, so yz goes up 1, 2, in the amount that it goes over 1, 2, right? So the slope for that is 2 over 2, or 1, right? That's rise. So slope equals change in x, or sorry, change in y divided by your change in x, or your slope equals rise over run. That helps you remember that. All right, so ST is your change in y is 1, 2, 3, right? Or you could figure it out by going here. Your change is going to be your initial minus your final minus your initial. So your final point, right, is -3. -3 minus initial point is -6. -6. So it's -3 plus 6, which is 3, right? And then your change in x is let's see, here is going to be your final point is 6 minus your initial point, which is 3 minus 3. Right, 6 minus 3 equals 3, which is 1. Right, that's another way to do it. If you have like really large spans to count, it's easier to do it that way. Right, this would have been just as easy to count 3 up and 3 over. But I wanted to show you the final versus initial. Remember, your deltas, your change in is always equal your final minus your initial. Okay. All right. So it's ST, but I guess it doesn't really matter because we're going TS because it's going this way. This way, your slopes are always counted from going left to right, no matter if it says ST. It's always going from left to right. All right. If a negative slope, so positive slopes do this, negative slopes do that. All right. Just know that when you're looking at it from left to right, it doesn't matter how the order they give you the letters. This is given to ST. Don't be deceived. That is still a positive slope. Just be like QT is a negative slope, right? ST is a positive slope. You could say TQ, it's still a negative slope, right? So if it's going downward, it's a negative slope. If it's going upward, it's a positive slope. It doesn't matter what order they give you the letters in. All right, WX, the change in Y is 2. 1, 2, the change in X is 1, 2, 3, 4. It's 2 over 4, that equals 1/2. Okay, and then QR, Q to R. I'll do this one the other way. So my change in Y is -3, and then the final is 0. -3 minus 0 equals -3. It goes up to, oh no, that's wrong. Sorry, my final is 0. Final is 0 minus -3 equals 3. Right, and then my initial. So my X, my final is 6. My initial is 0, and that's going to be 6. So it's still going to be 1/2. All right. So now what is the distance? What is the distance between here and here? All right. So the way you can do this one is with Pythagoras theorem. So that's how you're going to do this. W, Y, and Z. So Y and Z, I'm going to draw a right angle here. Right, I'm going to make Y and Z, I'm going to make a triangle here, and this is my right angle. Pause it for a second. Think on it. So this is my right angle here, and if this is my right angle, then this is my X, this is my Y, and this is my Z. Okay, so I'm looking something like this. All right, so to figure out the distance between my Y and my Z, this Pythagoras theorem is going to be my X squared plus Y squared equals Z squared. Right, so to solve for Y here, it's going to be Z squared minus X squared equals Y squared. Y squared equals Z squared minus X squared. And I'm going to put a square root in between both of those. So z squared plus or minus x squared minus x squared. All right, so that's going to be equal to, all right, my z is 1, 2, 3, 4 squared. 4 squared is 16. My x, pause this. So I'm going to do some more math on this one. So this is 2. This is 1, 2, 3, 4. This is 4. This is 2. Right. So then I'm going to figure out what this is here. All right. So now I can figure out what my value. I already know my value is z. All right. It was right in front of me the whole time. Okay. So I'm going to put this here and put 1 right there. All right, now I have this. This is 2. Okay, and then this is 2. So this is 2 squared. Erase all this stuff. All right, so this is 2 squared. This is 2 squared. So 4 plus 4 squared is 8 squared. So this y value here, or the z value now, is z value, which we're looking for here, is going to be equal to the square root of 2 squared plus 2 squared, right? So we need a little half triangle here. So it's 2 squared plus 2 squared, and that's that. So that's going to be equal to 8 square root of 8, which equals to, remember, that's going to be 8 times 2, or sorry, equals square root of 4 times 2, and I'll take the perfect square out of that is 2 square root of 2 equals 2 times the square root of 2. All right, so that's how you do that one. So yz here is 2 square root of 2. Alright, now we have st. And I wrote all up inside that. So, but it's the same concept. I'm going to do the same thing. I'll do it in blue instead. Blue is right here. That is my right triangle right inside there. And then this is going to be, this is 1, 2, 3, this is 3, so this is going to be equal to the square root of 3 squared plus 3 squared, which equals 9 plus 9 is the square root of 18. 18 equals square root of 9 times 2, and that's going to be equal to the square root of 3 times 2. Equals 3 times the square root of 2. Alright, so then we got wx. So that's this one right here. So wx is right angle, right triangle. This one's 2, and that's going to be 2, so this is going to be 4. So this whole thing is 4, and that's going to be 2, so that's going to be equal to the square root of 2 squared plus 4 squared. That's going to be equal to 4 plus 16. It's going to be equal to the square root of 20, which equals 4 times the square root of 5, or times 5 equals 2 to the square root of 5. Equals 2 to the square root of 5. All right, then we got QR. QR is a big one. Big one here. Let's see. I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So QR equals square root of 6 squared plus 1, 2, 3, 9, or 3 squared, which equals 36 plus 9. And add those together equals 45 equals square root of 8 times 5, which equals the square root of, wait, there's a 9 in there. 4 times, no, that's 9 times 5. 9 times 5. 9 times 5 is 45, which is going to be 3 square root of 5. Square equals the square root of 3 times 5. Square root of 3 times square root of 5. So that's that one. Okay, that was a little tricky. It's been a while since I did that. Alright, so now I need to show, oh man, I gotta show the dilation. I'll use it red. I'll use red. Show the dilation on the coordinate plane. Okay, so I will. Alright, so now to show the dilation. The dotted lines to each vertex. Alright, so now I need to show the dilation on the coordinate plane by dotted lines. So gotta go through each vertex of the expanded points. So each point that was dilated, and that will show you where the point of dilation is. And you'll see it's right there at O. There you go. That's a red line. Red. Back up. Red line is the red dotted lines. Red dotted lines. Okay, what's the scale factor? All right. Write a description of the dilation by giving the center of dilation. All right, so we need to figure out what the scale factor is. So the scale factor is going to be, let's see. This is the before. Okay, so the initial one is the W. Oh, this is the dilation. So this got smaller. This is the after. After the dilation of, this is before. So this shrank. This shrank. Therefore, the scale factor is going to be less than 1. All right. So the scale factor is going to be less than 1. So the bigger number has to be on the bottom. Right? Is a dilation of, so this is 1, 2, 3, 4, 5. Oh no, I need to just do this one. This will work. Yeah, why not? This is 1 from this, the slopes are the same. So this is going to be, oh, it changes the same. Yeah, so this thing changed 1. So the slopes for WX is it changed 1, 2, 3, 4. Oh, sorry, for WX. Let's do this will be the numerator. So for the small one, that's small one is going to be, let's see, 1, rise is 2, run is 1, 2, 3, 4 is 1/2. Okay, and then the big one is going to be 1, 2, this is going to be 1, 2, 3, and then 1, 2, 3, 4, 5, 6. All right, so it's big one is 1/2. So our scale factor here let me see this. It went from 1, 2, 3, 4, 5, 6 to 1, 2, 3, 4. So it's 4, 6, or 4 or 3. This doesn't work. Yeah, so it's actually 4, 6 or 2/3. So 2/3 is the actual. That's the best way to do it. Is 1, 2, 3, 4. And both have the same slope. This is how you check that they both have the same slope, right? And because of that, you can go 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6. They cover the same length. All right. So there you can go. Scaling factor was 4 over 6 or 2/3. All right. So your description. And your origin. Scale factor 2/3 point of dilation equals origin, or 0, 0. Okay, ratio of OX O to X is 1, 2, 3, 4. So it's going to be OX to OR. So OX to OR. So 1, 2, 3, 4 to 1, 2, 3, 4, 5, 6. So it's going to be 2. So this is 4, 6 or 2/3. And then OX to OR. So this is going to be 1 OX to OR is 1 OX to XR. Okay, XR is 1, 2, and OR is 6. So it's 2, 6, 2, 6, or 1. Wait, no, wait. OX is 6. OX is 1, 2, 3, 4. OX is 4. And XR is 1, 2. OX is 2. Okay, so that's 2. All right. Yeah, there you go. So that's how you do that one. That one's a little long, a little rusty, but hopefully that helped you out. Have a good day.